Welcome to the Tech Mechanic. Today's breakdown is part of our Azure Architecture Master Series. If you want the full roadmap, then hit the playlist from the start. With that said, let's dive into today's topic. Imagine it's Monday morning. Your e-commerce application is running normally. Suddenly, someone accidentally deletes an important production resource. Customers can't access critical data. The team starts asking one question: can we recover it? This is where backup and recovery become critical. And today we are going to understand how Azure Backup helps architects protect Azure workloads from accidental deletion, corruption, and other data loss scenarios. Before we go further, let's clear up an important architectural misunderstanding. High availability and backup are not the same thing. High availability is about keeping your application running when something fails. Backup is about recovering data when information is deleted, corrupted, or otherwise needs to be restored. You can have a highly available application and still lose important data. That's why a production architecture needs both availability and recovery strategies. Azure Backup is Azure's managed backup service for protecting supported workloads and enabling recovery when needed. The basic idea is simple. We configure what should be protected. Azure creates recovery points according to our backup policy. If something goes wrong, we can use those recovery points to restore the workload or data. For architects, the important concept isn't simply clicking the backup button. It's designing the right backup, retention, and recovery strategy. One of the key concepts you will hear with Azure Backup is the Recovery Services Vault. Think of it like a secure digital vault. Backup configuration and recovery information are associated with the vault. The vault becomes an important part of our recovery architecture. And because we are talking about recovery, security of the vault itself is extremely important. Azure Backup supports multiple workload scenarios. A common example is protecting Azure virtual machines. It can also be used for supported Azure services and hybrid scenarios. The exact capabilities depend on the workload and backup configuration. So when designing an architecture, don't simply ask, "Do we have Azure Backup?" Ask, which business-critical workloads are protected, and how would we recover them? Now we come to one of the most important architectural decisions: the backup policy. How frequently should backups run? How long should we retain them? Do we need daily recovery points? Do we need weekly, monthly, or yearly retention? These aren't just technical decisions. They should be driven by business requirements. This is where two very important architecture concepts come into play. RPO, Recovery Point Objective. How much data can the business afford to lose? And RTO, Recovery Time Objective. How quickly must the application or service be restored? For example, if our RPO is 15 minutes, losing 8 hours of data is unacceptable. If our RTO is 1 hour, taking an entire day to restore the application isn't acceptable. Backup architecture must align with these business objectives. Another common source of confusion is backup versus snapshots versus replicas. A backup is designed primarily for recovery and retention. A snapshot provides a point-in-time copy for supported scenarios and can be useful for rapid recovery or operational purposes. A replica is typically about maintaining another copy of a workload for availability or disaster recovery. These mechanisms solve different problems. A strong architecture chooses the right one based on the recovery requirement. Now let's move into the Azure portal. I'll search for Recovery Services Vaults. This is where we can create the vault that will be used for our backup configuration. After login to Azure portal, and I will select the subscription and resource group. If resource group is not created before, then create by selecting the appropriate region. In the top search bar, type Resiliency or Recovery Services Vaults and select it from the services list. On the Recovery Services Vaults page, click the plus Create button in the top toolbar to open the Creation wizard. Under the Basics tab, select your subscription and target resource group. Next, enter a unique vault name, and choose the region where your workloads reside or where you want your backup metadata hosted. Inside your newly created Recovery Services Vault menu, look under Settings on the left menu and select Properties. Under the Backup Configuration section, click Update to open the Storage Settings pane. In the Backup Configuration panel, select your storage replication type, such as locally redundant or georedundant. Keep in mind that georedundant storage provides higher data durability across paired regions, and this setting cannot be changed once you start protecting items in the vault. If you selected georedundant storage, you can enable cross-region restore. This allows you to restore your workloads in a secondary paired region during disaster recovery drills or actual outage scenarios. Once selected, click Apply to save your settings. With storage redundancy configured, return to the Vault Overview page and click plus Backup from the top menu bar to begin adding and protecting your Azure workloads. Now we can define the backup policy that determines when recovery points are created and how long they are retained. This is one of the most important screens from an architecture perspective. Here we define our backup frequency and retention. Notice that backup isn't simply take a copy every day. We need to decide how many recovery points the business needs and how long they must be available. These settings should come from our RPO, RTO, compliance and business continuity requirements. Now let's look beyond configuration. In a real enterprise environment, we need to know whether our backups are actually succeeding. That's why monitoring backup jobs is just as important as configuring the backup policy. A backup that was configured 6 months ago but has been failing for the last 3 months is not protection. It's a false sense of security. Architects should design not only backup, but also backup monitoring and alerting. Now comes the most important test. What happens when disaster actually occurs? We identify the appropriate recovery point. We choose the recovery option. We perform the restore. And then we validate the application and the recovered data. Because here's a critical architecture principle. A backup strategy isn't proven until recovery has been tested. Now let's look at Azure Backup from the solution architect perspective. We start with business requirements. What is our RPO? What is our RTO? What are our compliance and retention requirements? From those requirements, we design our backup policy. Then we protect the appropriate workloads. And finally, we monitor backups and regularly test recovery. That's how backup becomes part of enterprise architecture rather than simply another Azure checkbox. Let's finish with an architect challenge. Your production VM is accidentally deleted. The business tells you, we can lose at most 1 hour of data, and the application must be restored within 2 hours. What should your architecture provide? A snapshot? A larger VM? Another load balancer? Or a properly designed backup strategy with appropriate recovery points, retention and a tested restore process? The answer is backup plus a recovery strategy designed around the business RPO and RTO. And remember, backup is not about making copies. Backup is about being able to recover when those copies are needed. Whether your goal is to become a solution architect, cloud architect, AI architect, or simply a better software engineer, the Tech Mechanic is your learning destination. Like this video, subscribe, and hit the bell icon to stay ahead in your tech journey.